To find the x-intercept, we're going to set y equal to 0. And to find the y-intercept, we're going to set x equal to 0. Let's find the y-intercept first. So y, remember, is the same as f of x. So what we're saying is that 5x squared plus 7x plus 2 over 2x squared minus 8, that this is equal to 0. If a fraction is equal to 0, that means the numerator is equal to 0. So what this means is that 5x squared plus 7x plus 2 equals 0. To solve this, we can factor. This is going to factor as x plus 1 times 5x plus 2. When this is equal to 0, what we're really trying to find are the zeros for our polynomial. So for x plus 1, that 0 would be x equals negative 1. For 5x plus 2, if we solve that to get x by itself, we end up with x is negative 2/5. So we have, for our x-intercepts, negative 1, 0, and also negative 2/5, 0. To find the y-intercepts, what we're going to do is we're going to set all the x's equal to 0. Remember that the equation or the function was 5x squared plus 7x plus 2 over 2x squared minus 8. So if we set all the x's equal to 0, it's going to become 5 times 0 squared plus 7 times 0 plus 2 over 2 times 0 squared minus 8. 5 times 0 squared is just 0. 7 times 0 is 0. So when we work out the numerator, we're just going to end up with 2. 2 times 0 squared is 0, and 0 minus 8 is negative 8. And so we end up with negative 8 in the denominator. This reduces to negative 1/4. So our x-intercept, our y-intercept is going to be negative 1/4, 0, comma, negative 1/4. To find a horizontal asymptote, we can use the three cases represented by the mnemonic Bobo, Bottom, eats DC. So Bobo means bigger on bottom. So let's test these cases out. Here's 2. Here's 2 for the degree. The degree is not bigger on the bottom, so it's not Bobo. Again, the degree here was 2. The degree here was 2. So it's not bigger on top. It's actually the same. So in this case, the exponents are the same. So that means that we need to divide the coefficients. And by coefficients, we mean the coefficients of the leading term. So that would be the 5 and the 2. If we divide the 5 and the 2, we get 5 over 2. So y equals 5 over 2 would be our horizontal asymptote. To get the vertical asymptote, what we need to do is to concentrate on when is the denominator going to equal 0. So when is 2x squared minus 8 going to equal 0? We could solve this by trying to get x by itself, but we could also solve this by factoring. If we factored it, it would look like 2 times x squared minus 4. But as we know, x squared minus 4 is the difference of squares, and x squared minus 4 can be factored as x minus 2 and x plus 2. So if we were to solve this for x, this 2 here doesn't even have an x, so that's not really going to matter in terms of trying to figure out what values of x make this 0. When we focus here, we know that x has to equal 2. That's the root for that particular factor. For this factor, x is equal to a negative 2. So our vertical asymptotes would be at x equals 2 and x equals negative 2. We do want to be careful though, because even though we said that we have asymptotes of x equals 2 and x equals negative 2, it is possible that one of them could have actually have been a whole. So how would we check for that? Well, we would have to take the original polynomial, original rational function, factor the whole thing and see if we have any factors in common. So if we factored 5x squared plus 7x plus 2, it would factor as x plus 1 and 5x plus 2. If we took the denominator and factored it, we already know that that's 2 times x minus 2 times x plus 2. Notice that none of the factors cancel out. X minus 2 does not have x minus 2 in the numerator. X plus 2 does not have x plus 2 in the numerator. So there's nothing that's going to cancel out. So there are no holes in this particular graph. To find if there's a slant asymptote, what we would need to do is to determine if the numerator has a degree of exactly 1 more than the denominator. If we notice that the degree here is 2 and the degree here is 2. So in the numerator, the degree is not 1 more than the denominator. So that means that there is no slant asymptote, that there is none. So in terms of our holes, we already stated that if we factored the numerator, that it would end up being x plus 1 and 5x plus 2. The denominator would be 2 times x minus 2 times x plus 2. There are no factors that cancel out, so we would say that there are no holes. So let's describe the attributes and see if we can put it together to do the graph. So we said that the x-intercepts were negative 2/5, comma 0, and also negative 1, comma 0. We said that the y-intercept was 0, comma negative 1/4. We said our vertical asymptotes were x equals 2 and x equals negative 2. We said that our horizontal asymptote was y equals 5/2. We said that we did not have a slant asymptote and we had no holes. So let's put some of these features on the graph. So negative 1, 0 is here. Negative 2/5, 0 is here. We had asymptotes at positive 2, so x equals positive 2 was a vertical asymptote. And also x equals negative 2. Five halves is 2.5, and 2.5 was our horizontal asymptote, so we're going to draw a horizontal asymptote here. One thing that we need to check is whether our graph crosses the horizontal asymptote or not, because we know that that's a possibility. So we wanted to determine, or we need to determine, if 5 halves will ever equal 5x squared plus 7x plus 2 over 2x squared minus 8. So what that would mean is that we would end up with, if we do the cross product, we're saying that 10x squared plus 14x plus 2 equals actually plus 4 equals 10x squared minus 8. If we subtract 10x squared from both sides, the 10x squares are gone. We're left with 14x plus 4 equals negative 8. This will have a solution. If we subtract 4 from both sides, we end up with 14x equals negative 12. We divide both sides by 14. And so we end up with x is equal to negative 12/14, which is basically negative 2/7. Actually, let me make a correction. This should have been a minus 40 here, in which case this should have been a minus 40, and this should have been minus 44, and that's going to be a different value. So x equals negative 22/7, which is going to be a little bit over negative 3, so negative 3 1/7. So negative 3 1/7, so it's going to cross maybe about here. We know that the y-intercept was 0, negative 1/4, so that's going to go here. So what we can do is we can actually start sketching the graph now. If we follow the pattern of what the graph appears to be, the pattern shows that the graph looks like it's going down. We know that it's not going to cross the vertical asymptote, so on that side, that's what the graph looks like. On the other side, we can choose test values to verify this, but it's going to be going down also. One thing to note is what the denominator was. Remember that when we looked at the denominator, it was 2 times x minus 2 times x plus 2. So if you notice that the power here is 1, so it's an odd value. And remember that for odd functions, what happens is that one end is doing something different from another. Well, it turns out that the same thing happens when we talk about graphing these kinds of functions. If you notice right here on this side, it's going down. So on the opposite side of our asymptote, we expect that it's going to be going the opposite direction. So this is what we anticipate should be happening. And that really is because of the odd power or powers that we have here. So if we continued, we know that we'd meet this point, it crosses, and then it stays really close because it's a horizontal asymptote. It only crosses one place because we only found one number where it crossed. So if we figure out the other part, again, if this is going down, then on the other side, it has to be going the opposite direction. So that's how we can get the graph for that particular problem.